Welcome to The Explainer. Today, we're pulling back the curtain on the invisible intelligence that keeps our biggest, most complex buildings running. We're talking about the hidden tech that, well, basically lets these massive structures think. I mean, have you ever really stopped to think about it? How does every single floor get the right water pressure? How is the temperature perfectly managed from the basement all the way up to the penthouse? It's not magic. It's an incredibly complex, interconnected network. And in this explainer, we're going to see exactly how it all works. So, to really get our heads around this, let's stop thinking of a modern building as just concrete and steel. Instead, think of it like a living body. And just like any body, it needs a nervous system to sense what's going on, react, and keep everything in balance. And that, right there, is the core idea of a smart building.
But here's the thing. Even with this idea, a lot of modern buildings are facing some pretty serious challenges, and they're often completely invisible. We're talking about silent failures happening behind the walls that can lead to major inefficiency, discomfort, and, even danger.
The real issue here is this tough shift from the old way of doing things, relying on someone to manually check a gauge or just plain guessing fuel levels, to a new era of truly reliable automation. This new way, it demands precise data, systems that actually talk to each other, and one single point of control.
Okay, so let's break these problems down. First, you've got these utility and management failures. This is the stuff you actually feel as a resident or a worker. The water pressure suddenly drops on the 30th floor, or one office is an absolute icebox while the one right next door is a sauna. It's all a direct result of guesswork and not having real-time data.
And what's even more alarming are the safety blind spots. I mean, just imagine a fire breaking out and nobody realizes that the sprinkler system doesn't have enough pressure to work. This is what our source calls fire system blindness. When the critical systems for fire, for ventilation, even for the server rooms don't communicate with each other, you end up with these massive, dangerous gaps in safety. So how in the world do you fix these cracks in the foundation? Well, you solve it by giving the building a full set of digital senses. And this is where smart instrumentation comes in. It transforms the building from just a passive structure into an active, responsive environment. Smart instrumentation is essentially the hardware of the building's nervous system. Think of it as a network of highly accurate sensors and transmitters that act as the building's eyes, ears, and nerve endings. They gather incredibly precise data on literally everything that's happening and shoot it all back to a central brain, which is called the building management system. This whole technology works on a simple, but honestly incredibly powerful feedback loop. A sensor senses something, let's say the water pressure dropping. It then transmits that information to the central system. The system analyzes it, realizes it's too low, and then it automatically sends a command to control the booster pump to ramp up the pressure. Sense, transmit, analyze, control. This loop is running constantly for hundreds of different things all at once. Okay, so let's dive into the toolbox. If we're giving a building these digital senses, what are they exactly? Well, we can break them down into 4 essential tools that measure pretty much everything from force to flow. First up is pressure, which you can think of as the building's sense of touch. These sensors are the silent guardians, making sure that all the critical systems have the right amount of force. Take those fire sprinklers. These sensors are constantly monitoring the line, making sure that if a fire ever does break out, there is exactly enough water pressure to handle it. It's all about moving from just hoping it works to knowing it works. Now, what's really fascinating here is that not all sensors are created equal. For a simple water tank, a standard transmitter is totally fine. But for something like a gas line, you need this smart transmitter. It's ATEX and SIL certified. That's a global safety standard that basically means it's explosion-proof and has a ton of fail-safes built in. And that IP67 rating, that means it's fully waterproof and dust-tight. It just goes to show, for the really critical systems, you need military-grade precision and reliability. All right, our next tool is the flow meter. Now, if pressure is the force, flow is the volume. These things are absolutely crucial for efficiency. By measuring the exact flow of chilled water for the HVAC system, a building can avoid overcooling and wasting just enormous amounts of energy.
It's how you precisely match your energy use to what the building actually needs at any given moment.
Next up, we have level transmitters, which are kind of like the building's ever-watchful gauges. They prevent disaster by making sure you never, ever run out of critical resources. Just think about a hospital during a power outage. These sensors ensure the building manager knows exactly how much diesel is left for the backup generators down to the second.
And finally, we have temperature, the sense we probably all notice the most. These sensors are the real reason you don't have to constantly fiddle with a thermostat. They monitor everything from the main boilers to the air in a single conference room, letting the central system make all these tiny micro adjustments that keep everyone comfortable while running that huge HVAC system as efficiently as possible.
So here's the crucial point. When you connect all of these digital senses, the pressure, the flow, the level, and the temperature, you're not just gathering data for the sake of it. You're actually working towards a much bigger goal, which really breaks down into 3 key outcomes.
First, buildings become smarter. They go from being reactive to being proactive. The system doesn't just fix problems anymore. It actually starts to anticipate them. It gives you these incredibly valuable insights into how the building is really being used, which allows for constant optimization.
Second, they become undeniably safer. With constant, reliable, and totally automated monitoring of fire systems, ventilation, and other critical infrastructure, you completely eliminate those dangerous blind spots that are caused by human error and systems that just don't talk to each other.
And third, they become way more sustainable. By precisely measuring every single drop of water and every unit of energy, the building can optimize its consumption, which drastically reduces waste and its overall environmental impact. And look, that isn't just good for the planet, it's really good for the operational budget.
So really, what this all shows is a fundamental shift in how we build. And this isn't science fiction anymore. This technology is being installed all around us right now. The spaces where we live and work are literally growing a nervous system, becoming more aware and more responsive to us.
And that leaves us with a pretty fascinating question to think about. Now that our buildings are developing these digital senses of touch, temperature, and flow, they're starting to learn. They're learning our patterns, our needs. So the big question isn't if they can sense us anymore. It's what will they learn to do for us next?